Everyone, so in this video we are going to discuss another very important topic of AS physics, diffraction grating, and we are going to cover these objectives, okay, in this video. So let's start with the definition of diffraction grating, how we can define it. It's an optical instrument. What is optical instrument? Anything that deals with the light, right? And it creates a diffraction patterns, and we already know diffraction patterns are the bright and the dark fringes when a monochromatic single wavelength light pass through it. And this is the diffraction grating thing, right? This rectangular plate. In this plate there are number of lines through which the light can pass, and this whole thing is called the diffraction grating, and it will be placed on some stand like this. This is commonly available in labs, and if you see, there is a written 600 lines per millimeter, so it is showing how many slits are there in a diffraction grating. Okay, so it can be in centimeter, it can be in meter, so this is how it is. So let's begin how we can solve the equation, how we can find the unknown things by it. This equation that is shown on the screen is called the diffraction equation. Okay, so in this D is showing the separation between the two consecutive slits. Let's suppose one slit is there, one slit is there. What is the gap between them? This is the D. And sine theta, theta is basically the angular angle between the maximas. Okay, I will show you the picture how we can define it. N is the order of the maxima. Maxima is the constructive interference where the bright fringe will be, and lambda is the wavelength. Okay, so and total number of lines on a diffraction grating is represented by n, and a separation between two consecutive lines is represented by d, and relation between the n and d is like this. They are reciprocal of each other. Okay, and this is the picture of different diffraction gratings. This diffraction grating is showing 100 lines per millimeter, this is 300 lines, and this is for 600 lines per millimeter. So diffraction grating is available in different sizes. Okay, so this was I was talking about the angle, the theta. So the middle maxima, this is called the zeroth order maxima, and the next maxima above or the next maxima below is the first order maximas. Okay, so if you have to find the angle will be made from the zeroth till the first. This will be called theta 1. If you have to find the angle of the second maxima, you will measure it from between the zeroth and the second. It will be called theta 2. Okay, so so how many maximas are possible? What is the order of highest maxima that you can get? So for maxima order, theta can be equals to 90. Okay, and when you put here 90, sine theta is equals to 1. So the equation that was n lambda is equals to d sine theta. This sine theta will be 1, so n lambda will be equals to d, and n will be equals to this thing, n is equals to d by lambda. So if you find the ratio of separation between the two slits and the wavelength, it will give you how much, how many maximas are possible in that diffraction grating. Okay, and let's suppose what you're getting is in fraction, in decimal, 2.7. Then you have to round it off to the lowest, to the lower side. Okay, because 2.7, they should be in a integral number. Okay, so it will be rounded off to 2. Okay, so let's begin. This was the short overview of the topic. Let's start the questions. The question we have is from May June paper 25, and it's question 30, in which what we have to do, they're asking us light of wavelength. We have lambda here. Let me write it side by side so we can better understand it. Lambda is given, is incident normally on the diffraction grating with 450 lines per millimeter. So this is the n, total lines per millimeter. What is the angle of diffraction of the second order? So you have to find for the second order. So n is given, small n. Okay, you have to find theta. So lambda is 680 nanometer, n is equals to 2, and capital N, number of lines per millimeter, is 450 lines per millimeter, and theta you have to find. If you see what equation we have n lambda is equals to d sine theta. So what we have n, we have lambda, but we don't have the d. Okay, to find theta. So we need theta. For theta, you first have to find d. Okay, I know d is equals to 1 by, sorry, d is equals to 1 by n. Okay, and we have to convert all of them in SI units. So what the challenge is here, it is given in per millimeter. You have to convert in each and every question into a meter. If there are in 1 millimeter, if there are 450 lines, okay, so how many lines will be there in 1 meter? Okay, if you see the relation between millimeter and meter, meter is, if you multiply this thing with 1000, then you get the meter. Okay, meter is 1000 times greater than the millimeter. Okay, so if in 1 millimeter there are 450 lines, then the length that is greater 1000 time will have 1000 time more lines. Okay, so you can also try the ratio proportion method. Okay, you can solve it by that thing. You can what we can do, we can write 1 meter, and if this thing can be written as 1000 millimeter, so 1 millimeter over 1000 millimeter is equals to 450 over x. If you want to do it like this, so x will be equal, this milli cancel, 450 into 1000. Okay, so you can do it like this if you want to. Okay, this is number of lines, so it is 450, or you can just keep in mind that if the length is 1000 times more, the lines will also be 1000 times more. So you can find the d here, it will be 450,000. Let's do the calculation. It will give you 2.2 10 raised to power minus 6. Okay, and now we can find the theta. If you have to find theta, you have to rearrange this equation. So it can be written as n lambda divided by t is equals to sine theta, and theta will be equals to sine inverse n lambda divided by t. Just put the values. Sine inverse n is 2, lambda is 680 nano, nano is 10 power minus 9, divided by d is 2.2 10 raised to power minus 6, and you will get the answer 38 degrees. Okay, so it's option D. Let's move to the next question. And next question, this is also from May June variant 1 to question 29. What we have our student use a diffraction grating to determine the wavelength of a visible light from a source. The diffraction grating has this much line, so we have n. Let's write it down. What we have, n is 3,300 lines per millimeter. So let's change it into meters. So you will simply multiply this thing with 1000. It will give you lines in meters. Okay, so it will be 300,000 lines in meter. Okay, per millimeter, it was per millimeter. So okay, so what we have to find in this, the student measure the angle theta of the order n of the intensity maxima. A graph of n against theta is plotted. The line of the best fit for the plot is shown. Achha, gradient is g. If you see the graph, gradient g is rise over run. Rise is n, run is sine theta. Okay, that is also given. Which expression represents the lambda? You have to find expression for the lambda. Okay, let's work it out. We know n lambda is equals to d sine theta. So you can write as lambda is equals to d sine theta divided by n. Okay, as we know, n over sine theta is equals to g from this thing. So I can write as 1 over g is equals to sine theta over n. You have to take the reciprocal. So here we have sine theta over n, so it is 1 over g, right? So it can be written as d over g. And d value we already have, d, no, we don't have, we have value of n. So to find the value of d, we can do 1 over n, that is 1 divided by 300,000. This thing will give you, when you divide it, d is 3.3 10 raised to power minus 6. Okay, so we will get 3.3 into 10 raised to power minus 6 divided by g. So this is option C. Let's move to the next question. This is variant 1.4, May June, question 28. What we have, electromagnetic wave with incident, normal and diffraction grating. The second order maxima, n is equals to 2, is produced at an angle of 30° to the direction of the light. The diffraction grating has these much turns, so you have n, that is 5,000 lines. Okay, this time it is in centimeters. What is the wavelength? You have to find lambda. So this is in centimeters. Okay, so if you have to change it into the meters, you know there are 100 meters, 100 centimeters in 1 meter. So it's a 101 ratio. So you simply have to multiply this thing with 100 if you have to convert into per meter. Okay, previously it was in per centimeter, I have converted into per meter, so it will give me 500,000 per meter, lines per meter. So to find lambda, we have to use the equation, and lambda is equals to d sine theta. Lambda is equals to d sine theta divided by n. So let's put the values. We don't have the d, so we have to find the d as well. So d is equals to 1 over n, that is equals to 1 over n is 500,000. So it will give us 2 into 10 is to the power minus 6. Okay, so let's put this value there. Let's solve it at this point. D is 2 into 10 raised to power minus 6. Sine theta is 30°, and n is basically 2. It will give you 5.0 10 raised to power minus 7 meter. Okay, this is lambda. It's option B that is correct. Okay, let's move to the next question. Light of wavelength 567, so you have the lambda 567 nanometer, is incident normally on a diffraction grating. The grating has these much lines, so you have the n 400 lines per millimeter. I'm changing it into the meter directly. Okay, simply multiply this thing with 1,000. This will be lines per meter. You can write it like this as well. So it will be 400,000 per meter. Okay, so what is the angle between the second maxima and the third maxima? So you have to find angle, which theta 3 minus theta 2. Okay, so let's find theta 2 first. For theta 2, n is equals to 2. So n lambda is equals to d sine theta. 2 into lambda is 567 10 raised to power minus 9. It's in nano. D we don't know, so we have to find d. D is equals to 1 by n, that is 1 divided by 400,000. So it will give you 2.5 10 raised to power minus 6 meter. So it will be 2.5 10 raised to power minus 6 and sine of theta 2. So theta 2 can be written as 2 into 567 10 raised to power minus 19. This 2.5 10 raised to power minus 6 will be divided, and you have to take sine inverse. Calculating this thing, you will get 26.97 degree. Okay, so now let's work out theta 3. For theta 3, n is equals to 3, so we will have 3 into lambda is 5, 6, 7, 10 raised to power minus 9. We have to repeat all the process, just have to change the values. 2.10 power minus 6 sine of theta 3. So theta 3 will also be sine inverse. You just have to replace 2 with 3. Okay, so 3 into 5, 6, 7, 10 raised to power minus 9. Okay, fine. It's this is also 9. Okay, minus 9 divided by 2.5 10 raised to power minus 6. So what you will get 42.87 degree. That is theta 3. That was theta 2. What you have to find? You have to find delta theta. So delta theta, theta 3 minus theta 2 is 42.87 minus 26.97. So you will get 15.9 degree. Okay, so it's option C that is correct. Okay, that's all for today. See you in the next video.